Completely primitive and particular integral. The solution of a differential equations containing the full number of arbitrary constants is called the complete primitive. Any solution derived from the complete primitive by giving a particular values to the constant is called particular integral. For example, the complete primitive of for the this one d cube by equals dx cube equals dy by dx is complete primitive, means our general solution we found as y equals a naught plus a1 sin x plus a2 cos x minus 1. So that is we found, or we can create this equation in that form where y equals c plus a1 sin x plus a2 cos x, where c equals a naught a0 plus a2, and that form. And we consider how we can form these two forms. This is called complete primitive, right? This one, and we will consider how we can consider these two types of forms, right? So this is our equation, right? So we can write this y equals a naught plus a1 sin x plus a2 cos x minus a2. I am taking minus a2 for here. A naught minus a2 plus a1 sin x plus a2 cos x. So I am introducing another constant c. So then we can write y equals c plus a1 sin x plus a2 cos x, where c equals a naught minus a2. That's how we got this equation y equals c plus a1 sin x plus a2 cos x, where c equals a naught minus a2. Or we can write this complete primitive in this form also. We consider how we can create that form. You know that so earlier we talked about hyperbola functions. So we know that sin x equals e x minus e to the power minus x over 2, and cos x equals e to the power x plus e to the power minus x over 2. So I am taking this again. So y equals a naught plus a1 sin x. Instead of sin x we can write ex minus e to the power minus x over 2 plus a2 times, sorry, I am taking this one, then that is easy, this equation. Okay, here c no, this one I taken, and c plus a1 sin x we can write, and cos x means e to the power x plus e to the power minus x over 2, right? So then we can write y equals c plus, we can remove the brackets. Here comes aex, a1 ex over 2, a2 ex over 2. So we can write a1 plus a2 over 2 ex. I remove that brackets. Ex times here, then ex a1 over 2 he is creating here, a2 ex over 2 creating here, and plus then e to the power minus x we can take out from the brackets. Then here create minus a1 ex. So minus a1 ex is creating there, a2 ex is creating there. I am introducing another constant a and b. So then we can write y equals c to plus a1 a times ex plus b times e to the power minus ex, where a equals half a1 plus a2 and b equals half a1 minus, sorry, a2 minus a1, right? That's how this is created. Yes, y equals c plus a to the power ex plus b times e to the power minus ex, where a equals half a1 plus a2 and b equals half a2 minus a1. Then this illustrates the fact that complete primitive may often be written in several different ways, but really equivalent. So by taking the particular integrals means that complete primitive means this is valid for all integers, right? All integers. But in the particular integrals means if we select some constants, and if taken that a naught is equal some value and a1 equals another value and a2 equal another value, then according to that values y is given a value, so that is called particular integral. So in here we taking y equals 4 and c equals 4, and then a1 a2 equals 0, right? Why is that? By using this one, y equals c equals 4, yeah, c equals 4, right? Then a1 and a2 0, right? Right, I'll explain that. Y equals c plus a1 sin x plus a2 cos x now. Then here taking c equals 4, a1 a2 equals alright, taking c equals 4 and a1 equals a2 equals 0, then we can write y c equals 4 plus a1 0 times sin x plus a2 0 times cos x. So y equals 4, right? That is a particular integral, right? Then that's why how y equals. Then by taking a1 5 a2 c equals a2 equals 0, right? Then now y c0 plus a1 5 sin x and a2 equals 0 cos x, then y equals 5 sin x. That's how y sin x is created. Then likewise taking a2 that value, a1 value as c1 minus 4, then you can take y equals cos x minus 4. And also then this is substitute for the other equation, this one here given c equals 2 and a equals 1 into e to the power x plus b equals minus 3, it means minus 3 e to the power minus x. So y equals 2 plus ex3 e to the power minus x, right? Yes, that's how it is created. These are particular integrals. Okay, then graphical representation, right? We shall now give an example of method of sketching rapidly the general form of the family of curves responding to the complete primitive of dy by dx equals f of x comma y, where f of x comma y is a function of x and y having a perfectly definite values of x and y. The curves of family are called the characteristic equation. So the curves of families are called characteristic equation. As an example, here given dy by dx equals x times y minus 1. So we can take d squared y over dx squared equals x squared plus 1 minus x minus y. So we can take this example, right? So dy by dx equals x times y minus 1, no, x times y minus 1. This is the given equation. Yes, now we can write dy by dx equals xy minus x, no, and we can differentiate with respect to x. Then we can take d squared y over dx squared equals x times dy by dx plus y times 1 minus 1. So then we can take dy by d squared y over dx squared x times dy by dx plus y minus 1, right? And you know that dy by dx is x times y minus 1. So we can write d squared y over dx squared equals x times dy by dx means x times x minus 1 plus y minus 1, right? So we can simplify x squared times y minus 1 plus y minus 1. So we can take y minus 1 out from the brackets, then here create x squared plus 1. So then dy by dx equals x squared plus 1 times y minus 1. Okay, so when you know that concavity, how we can take the concavity, right? So if we take the second derivative, if it is greater than 1, that is concave up. It means those are convex, no? If we call convex this, it means if you take this graph is like this way, right? It has minimum, right? If d squared y over dx squared less than 0, that is concave down, right? It means that we call that is concave. It means it have a maximum, right? Okay, so here now if when d squared y over dx squared greater than 1, it has a concavity upwards. That's I explained when y equals 1. So this is our equation, d squared y over dx squared equals y minus 1 times x squared plus 1. This is always positive because this is x, any x value, this part is always positive because this is x squared. If you take a square of negative number, that is positive, no? So always this one is this term is always positive. So value of y is the effect to the if this is greater than or less than 0, right? So this is positive when y greater than 1, no? Y greater than 1, yes, this part is positive. That is negative when y less than 1, right? It is negative when y less than 1. If when y equals 1, what happen? This come 0. When y equals 1, there is come 0, right? So when if we consider dy by dx equals 0, what happen here? Y equals 1 or when dy by dx equals 0, dy by dx means x times y minus 1, no? So dy by 1 y equals 1, no? X equals 0, no? Right? It means there are turning points. The turning points of this family of curves is along x equals 0, right? Okay, those things we can find by using this, right? So yes, dy by dx, then x equals 0, then y, when y greater than 1, the characteristics will be concave up, then y less than 0 concave down, then y dy by dx equals 0, x equals 0, right? So then the maximum and minimum points lie on x equals 0 line. Because why is that? Because we found that dy by dx, when dy by dx equals 0, then value of x equals 0, then that is lie on the x equals 0 line. The characteristics near y equals 1, such is a member of family of flatter than those further from it, right? So then those consideration now up to family of curves. Now we can draw the family of curves like this way. If when y equals 1, that is parallel to x-axis, then dy by dx, it means y greater than 1, dy by dx, that is convex, no, it means concave up. And if y less than 1, it's concave down. These are the families of curves. I think you can draw like this when function is given. Right, now I think you have a clear understanding about how to identify a differential equation, and what are the coefficient of it, what are the differential coefficient of it, then how to find order, then how to find the degree of a differential equations, and how to eliminating the arbitrary constants and find the differential equation, and also to check to find the complete primitive and particular integral, and also drawing the family of curves for the given differential equation, right? So that is the summary of this lesson. So based on this lesson you have a tutorial, so you have to do this tutorial within the allocated time, and you have to submit it. And also if you have any problem related to this lesson, feel free to contact me anytime, right? I will be with you always to help you. Thank you very much.